We will now hear about the first German total diet study. Of course, we are very happy that we are in the position to give this presentation today. And to be honest, as Professor Schwertle indicated this morning, we would not be here if we would not be also part of the TDS network. So this is also a way to thank the community, the TDS community, for sharing their experience. Before I announce our speakers, I would also want to give credit to Gerhard Heinemeyer, who is in the audience. Some of you may know Gerhard, spiritus rector, so to speak, of the total diet study in Germany. He has been head of the unit for exposure assessment and started with a very successful lobbying for the total diet studies in Germany. I would like to introduce our two speakers. The presentation will be given by Oliver Lindner. Oliver is head of the exposure assessment, exposure standardization unit here at the BFR. This is a unit that is responsible for conducting all the nutritional and dietary exposure assessments. And therefore, it is the internal customer of our TDS data. Oliver has a degree in mathematics, and he leads the working group or the unit already that 2015. Oliver Lindner has also been a key investigator in the TDS exposure project, where we were able to collect the first information and the first practical experiences with conducting a TDS study in Germany. The presentation is co-authored with Irmela Savvan. Irmela is head of the TDS Study Center here at the BFR. Irmela cannot be present today, unfortunately, due to some family affairs. She cannot be with us today. She will join tomorrow. Irmela is a nutrition scientist, and she obtained her PhD in the Wageningen University, and we were really glad to have her in the team exposure assessment and exposure standardization, which later was outsourced into the TDS Study Center. So without any further ado, I would like to ask Oliver to talk about the BFR meal study, the first German TDS. Oliver.
Yes, thank you very much for this introduction. And first of all, let me apologize also Irmela, who wanted to be today here and to give the presentation for you, but as Matthias told, this was not possible at the end, and so I jumped in to show you today how we conducted our BFR meal study, and I'm also proud to show you some of the results we already obtained. BFR meal study is the first German total diet study, and we have this acronym MEALS for exposure assessment and analysis of foods, and put it together to the word meal. And in Germany, we have done a very specific type of total diet studies. We decided to have a modular approach in our total diet study. This is mainly due to methodological reasons. We decided to have separate sampling procedures for each of the substance groups to be analyzed. And to do so, we divided the substance groups into the different modules. And we think that we could so better consider the specific characteristics of each of the substances due to the different sampling. But of course, at the end, such a complex sampling also made some challenges in the logistics. We had a kitchen and we had, of course, also a shopping team. But when we calculated our sampling numbers, we recognized that it will not be possible to do all the sampling at the same time in the kitchen, and also the shopping could not be done at once. So we decided to have two field phases, the field phase 1 and field phase 2. And here you see how we have done the different modules. Here we started, of course, in the field phase 1 with the core module and with some other modules that are very near in the sampling procedure to the core module, like nutrients or PFAS. And we have in the second field phase, for instance, the food additives. We already talked about that after the presentation of Luc. That had a quite different sampling compared to the core module, so it would be better to put it into the second field phase. Besides this, we followed in our BFR meal study the usual steps for a total diet study that are well known for you and which I present here. And now I will introduce our study by following these 6 steps and give you some insights and some specifics for our study, and at the end I will present you some results. Okay. Sorry for that. First, I start with the food list. We have started with a food list of 365 foods that were selected to cover 90% of the average diet in the German population. German population means here the infant population as well as the adult population. Both are covered by this number of foods. And moreover, we also wanted to cover the 90% not only in total, but also in the 19 main food groups of the FoodX2 classification from EFSA, to be sure that not one main group is underrepresented at the end of the assessments. And out of these 365 foods, we selected some pools, and this ended up in 3,408 pools. And we divided our pools according to region, season, and production type. Not all of the 360 foods were divided into different pools, and we had an expert committee who advised us for which of the foods from the food list we should make the division by region or season or production type. For modules like the process contaminants, we had in addition some other pooling criteria and considered their different browning degrees. Okay, when we now come to the second step, the shopping, then we of course intended to be representative with each of our pool for this German consumer behavior. And to ensure this representativeness, we use data from 30,000 households. And bought some market share data that gave us information on the brands, the production type, and origin of the foods. And then, based on this data, we have done two types of shopping. One is at national level, the so-called national food list. There we then just pooled foods from different regions or from one region only and considered, for instance, the brand information, as here for the pizza. That was the assumption behind that the pizza in the south of Germany is very similar to the pizza in the north of Germany, and that it does not make sense to have different samples per region and also not per season. And so here mainly the type of pizza and brand information was considered to select the pools or the subsamples to put together to one pool at the end. And of course we also considered then all the other issues you can see here. And as you can see here, the next is the preparation of foods. Also there we wanted to mimic the consumer behavior as much as possible. And you all know that food surveys normally does not give such level of precision on the food consumption, and you will miss some data on the food's origin or production method. And so we had to do some additional surveys to ensure that we really cover representative consumption or not consumption behavior, representative behavior in the kitchen when preparing the foods. And there were 3 surveys mainly on used kitchen utensils in German households, on preparation of foods, for some foods that are where it was not clear how it is, what is the preferred preparation method in German households, like for instance cooking rice or preparation of coffee and so on. And a third one was to understand which degree of browning is preferred for grilling meat or making pommes frites and so on. And this information then was used to decide on the methods used in our kitchen by our team that you can see here. At the end we have pooled together 50 subsamples when we have a regional or seasonal sampling, and 20 subpools when we have sampling only on national level. And yes, we used then different kinds of to store this homogenized samples. Depending on the substance, we use plastics or glass here for the storaging the samples and before it goes to the laboratories. And now we are already in the analysis. We have mainly worked together with commercial laboratories and laboratories from federal chemical investigation offices. That means we have subcontracted most of our laboratory work, and only for very few selected substances we have analyzed it in-house. When we then proposed or asked for proposals and tendered the subcontracts, then we used our expert groups. We had advice from expert groups for each of the substance groups, and within these expert groups, there were several national experts on chemical analysis of the substance we wanted to use, and they advised us in the tendering specifications and also the quality measures to take to ensure that the results will be okay for us at the end. Okay, as I already told you, we had 2 field phases, and here you have a time schedule showing when we finished field phase 1, and you can see that we now also finished field phase 2 last year, and now we are in the step using the data, and for some of the data we also had to finish the plausibility checks. And here I also want to mention that we were supported during the whole field phase and also in the planning from an international advisory board. And here you can see some members of our international advisory board, and we are also happy that a lot of them are here today. Together with this advisory board that was mainly advising us on the methodological issues, we had expert groups, as I already mentioned, for the different substances that was then on the national level. Now I come to some of our results. Here you have at first an overview what we were able to publish already with respect to the occurrence data, and you can of course then have a look in more deep when you want to do so. Today I want to focus on some selected results out of this list, and I will start with substances that turned out to have high concentrations that were very near to the MPL. As you know, with pooled data, it's difficult to check the exceedances of any maximum permitted levels because you don't know whether all subsamples in the pool has a similar level or whether one have a very high level and the others very low levels, and there's some dilution. And so we decided for us to look to the pool data that exceeds the MPL over 80%, and then to give all the information on that pool to the food safety authorities so that they could take care of this data and to have additional checks in the food control. And here you see that, for instance, for non-dioxin like PCBs, we had a very high value in dogfish. We had an issue with buckwheat for the mycotoxins. Also, but that was not so surprising that for chlorate we had a lot of exceedances of the MPLs. Also for chlorpyrifos in dates. For copper, you can see it's mainly liver as expected, where we had an issue with also game meats. An issue that was more surprising for us was that we had not only for copper but also for other elements very high values in the chia seeds. And quite different is for the food additives. You have here in the at the end of this slide, benzoates and sulfides was analyzed also in pooled samples. So it's similar to what I told you about the MPL exceedance for the elements and PCBs and so on. But in soft drinks, I already told in the discussion before we decided to analyze the artificial sweeteners not in the pooled sample, but in all subsamples separately. So here we had real exceedances of the MPL that was detected by the BFR yield studies. But you know that the detection of exceedances of regulatory limits is not the main issue of total diet study. So now I come to the more representative data. Here I start with the PCDDF and DL PCBs and what level we found in our foods. And here the 15 highest values are presented. And you can see that cod liver is far above all the other values. All the values are given in wet weight here. I want to make aware you of that, even if, of course, some of them are normally given in per fett. And so, but here to better compare it, all were calculated in per wet weight. And you see that for the PCDDFs and the LPCBs, we have mainly foods out of the main group fish that were in the 15 highest values. And then also we had butter and sheep liver that was not out of the fish group. Other results here are presented, only the 5 highest values for phosphorus, calcium and potassium. And you can see here the different informations. What was here a little bit, surprising is that chewing gums turned out to have the highest cadmium, the highest calcium level of all the pooled samples we analyzed. But we checked it with our shopping list, and we noticed that in all of the chewing gums there was used calcium as a food additive. And so this is another source of calcium than we found as in the other samples, like from the cheese and milk products, where we of course expect the highest levels from natural occurrence. For the other groups, phosphorus, you will see here, it's also the cheese, but then you have also the seeds and the cocoa powder that turned out to have the highest levels. And for potassium, we have also the category of spices, legumes and nuts, and that considers all the top 2 and also the 5th highest value. The next substance I want to give you a short insight is the methylmercury. Here we analyzed, in addition to the total mercury content of all subsamples, of all pooled samples, sorry. We also analyzed methylmercury in fish and seafood. And here it's shown in, it should be green bars, but I think it's more gray bars. But in the darker one, you can see the exposure from the different pools for the fish. And beside, in the orange or yellow ones, you can see the consumption for the different fish species. And so you can see whether the exposure value given here is mainly due to the occurrence of methylmercury and high values of methylmercury in the pool, or more because of high consumption of this specific food type. And for pollock, for instance, you see the high exposure is due to the high consumption, and in contrast for tuna, you can see that there's not such a high consumption in the German population, and the high exposure is driven mainly by the high occurrence value of methylmercury in tuna. For comparison with a tolerable weekly intake, we can say that for methylmercury we have, for the most age groups, no exceedance of the tolerable weekly intake, but only in the young adults. Here in the red, we had an exceedance of the tolerable weekly intake, and this exceedance is mainly due to tuna consumption. And we already had today talk on iodine intake and on salt intake, and of course we also looked at iodine in our total diet study, and we used the total diet study data in a BFR opinion, and the background of the BFR opinion was that the iodine levels in the German population was declining in the last years, and so the risk manager wanted to know what to do to have a higher iodine exposure in the future. And to answer those questions, we have analyzed our BFR meal data. And here you have on the left hand the contribution of the main groups to the iodine exposure. Here for the products, iodine products from conventional production, but for organic production it is very similar. Therefore I have not shown it here as a graph. And you can see that iodine intake is mainly due to the food groups milk and dairy products, grains and grain-based products. Then contributors follow meat and meat products, and so on. And on the right side, this is again the highest contributors to the total iodine intake, but now not on the main group level, but on the level of the pools. And here you can see quite comparable. It's cow milk that contributes highest. Then a lot of water-based drinks like mineral water, but also drinking water are in the list of the 10 highest contributors. And in addition, you can also find some salami-type sausage or some wheat bread. This is probably mainly due to use of iodized salt during manufacturing of those food. And when we look now to the lessons we learned from analyzing the meal data for iodine intake, then the meal data confirmed that we have too little iodine ingested by the German population. Then we can say that with daily consumption of milk and dairy products, someone would be able to reach an adequate iodine intake. The same is for eating fish. When you eat it once or twice a week, this will help to reach the adequate intake on iodine. But from a risk management perspective, it's also a good idea to make more use of iodized salt in preparing the foods in the German households. And also it is possible to increase the iodine levels in salt without exceeding then the safe levels of iodine intake. And in addition to the increase of the iodine levels in the salt, it should also be looked for risk measurements that will help to use or to increase the use of iodized salt in industrially and handcrafted products, because at the moment it's only 30% in Germany used in this kind of products, and it would be good to increase it to 40% after, according to our calculations. Okay, now I come to one publication and to the results of this publication, comparing our food monitoring data and BFR meal study. We had already the question today, how to deal with food monitoring data. In Germany, we have a very good tradition of food monitoring data and using such data also for risk assessments. And but we, as you know, we started the BFR meal study to complement that, and one aim was not to reproduce the results of the food monitoring only. And so at the end of our BFR meal study, we now had a study looking on the overlapping of both programs and to provide an idea how to make best use of both data sources. And to do so, we have divided all substances analyzed in the food monitoring data or in the BFR meal study into 3 categories, category A, B, and C. And in category A, we have put it all foods that had at least 100, all substances that had at least 100 foods analyzed in our food monitoring. An example for category A is here cadmium, and you see cadmium is quite good covered already in the National Food Monitoring Program by a number of foods per main food category. And in the second group, it's category B. We put it all the substances where we had only a limited number between 25 or 100 foods analyzed in our national food monitoring yet. And you see here, for instance, for the PCBs, the number of foods analyzed in the food groups I have here on the slide is far below the ones analyzed on cadmium. And as you can imagine, the third category is the one with less than 25 foods analyzed in the national food monitoring yet. And one example of that is iodine that is nearly not analyzed in the national monitoring before. And in the next slide, you can see now the results looking to all the substances analyzed in the BFR meal study or in the food monitoring program. And we had an overlapping of 40% at the substance level. That means for these 40%, we had at least one food analyzed in the German food monitoring and one analyzed in the BFR meal study. But you can also see that for this 40% in the national food monitoring, it's mainly category C. That means that only a very limited number of foods was analyzed and only very little number of substances was from category A, where we had a good coverage of the foods list by both programs. And so we can, at the end, confirm that our intention to have a cost-effective approach to enhance the list of substances where we have now good data was successful, and that we did not reproduce results that were already on the plate for us. And in the same publication, we also provided comparison what are the typical methodological benefits or advantages and disadvantages for the food monitoring and for the total diet study approach, and how they can use together in the future. And we have developed a kind of decision tree for that. Of course, it starts with the question whether you have an acute risk or a chronic risk. And I think due to pooling, it's very clear that you follow for acute risk to from your left side and use the national monitoring data. But for the long-term exposure assessments, there are additional questions, how many foods are covered in the different programs, and then the decision tree will go on. But for a lot of substances where we have both data available, you need at the end an expert judgment, which is the best for the request you have to answer with your risk assessment. And here we have two examples how both programs already go hand in hand. And this is nickel in nuts and elements in chia seeds. Both turned out to have very high values in our total diet study. And we noticed that based on the pooled data we have in the total diet study, we cannot answer all the following questions, but there was no information from food monitoring data yet. So we proposed to have two programs for the food monitoring in the future, and the federal investigation offices agreed to do these two projects and to collect more information, more detailed information for those food substance combinations in the next year. And so we see that this can benefit from each other. If you want to see Irmela instead of me, and you want to know more about our total diet study, we have a nice animation you can use at our website and learn more about the study by going to our kitchen, and Irmela is answering a lot of questions there that would be too detailed for today. And at the end, I want to thank, of course, at first the study team. We could not do this study without our cooks, without our chopping staff, and all the others preparing the foods and to homogenize also very difficult matrices, and so many thanks to them. Without them, it would not be possible to present any result today. And of course, I also again want to say thank you to our International Advisory Board and our expert groups that has supported us. So then thank you also for your attention, and if you have any questions, I will try to answer them now.
Thank you very much, Dr. Lindner, Oliver, for this very nice presentation, showing some highlights of the first German TDS.